Welcome to the 3.5 notes for geometry. We're going to look at doing proofs, it's been a unit or so since we've done any proofs. We're going to specifically look at ones that have situations with parallel lines that are cut by a transversal. So it is important that we are these little rules that we're going to be using below, that we only use them if we're dealing with parallel lines. So if you have a situation where you have some lines that are not parallel and you cut them with a transversal, there are no relationships here between, for example, the corresponding angles. They're not going to be the same size if the lines aren't parallel. However, if our lines are indeed parallel to each other and we've been told that they're parallel, then what will happen is that we're going to see these relationships that we saw last section that will be true. We're going to have 4 angles here out of the 8 really obvious nonlinear pair angles are going to be congruent to each other, and then the other 4 angles will also be congruent to each other in a different way. And then each pair of angles that are forming a linear pair are going to add up to 180 and be supplementary. So because of that, we can make these statements that are true. Now, keep in mind the transversal is the line that's cutting the other 2 angles and intersecting it. These are these other 2 lines in 2 spots. And then we'll have 2 parallel lines. Maybe we'll call them A and B, whatever. We can call them whatever we want. And we'll know that they're parallel, and then we have these relationships that are true. Now, this first one is called a postulate, the corresponding angles postulate. A postulate, in case you haven't heard this before, is a statement that we agree to be true, but we can't prove it. We can see that it's true, but we can't necessarily prove it. It's something that is universally agreed upon, but it's observed, but there's no real way to prove it. But it's something that we are going to be able to count on as true. So something that is true is that if we have parallel lines, then any pair of corresponding angles that are formed are always going to be congruent. So angle 1 will be congruent to angle 5 if we have parallel lines. So if we know that M is parallel to N, then angle 1 is congruent to angle 5. Another pair of corresponding angles would be angle 4 is congruent to angle 8. Now those are going to be congruent in a different way than 1 and 5. We can also know that angle 2 is congruent to its corresponding angle, which is angle 6. That will be actually, those will have the same measure as 4 and 8. Hopefully you can look at the vertical angles there to kind of observe that. We will also have another pair of corresponding angles is that 3 and 7 will be congruent. So all of those sets of corresponding angles will be congruent, and you'll have really just 2 measures that are showing up for these 8 angles, and those 2 measures will be supplementary to each other and add up to 180. The next one is the alternate interior angles theorem. So if you have parallel lines, again, we have to have this hypothesis that is met. We've got to know we're working with parallel lines. Then a true relationship is that alternate interior angles are congruent. Now this is called a theorem. This is something that can be proven. This has been proven to be true. And so the way that this was proven was by starting with the corresponding angles postulate. If I kind of go back up here, let's say I've got some corresponding angles with 1 and 5 and another pair of corresponding angles with 3 and 7. We can observe that those are all the same size, or we can observe that those corresponding angles are congruent to each other. Well, but 1 and 3 are vertical, so those are congruent. And 5 and 7 are vertical, so those are congruent. And by either using substitution or the transitive property, we can see that really all 4 of those are the same. And notice that 3 and 5 are alternate interior angles. In a similar process, we could use that to prove 4 and 6 are congruent. So anytime you've got a pair of alternate interior angles, they're going to be congruent. So in this diagram, angle 4 is congruent to angle 6. Oh, sorry, let me start with the hypothesis. If we know that we've got parallel lines, having trouble writing today, then something that we know is true is angle 4 is congruent to angle 6 because those are alternate interior angles with parallel lines. We have another pair of alternate interior angles right here. Go Broncos, they need our help. Angle 3 is congruent to angle 5. Now, please notice the markings. 4 and 6 are congruent. That's one pair of alternate interior angles. 3 and 5 are congruent to each other, likely in a different way than 4 and 6. So these may not have, all four probably don't have the same measure. Kind of interesting question for you to think about. Is it possible for all four of them to have the same measure? And if so, what would those measures be? I'll let you think on that. All right, consecutive interior angles is also a theorem. This is something that has been proven. Now, the way that this one was proved also started with the corresponding angles postulate. Remember, 1 and 5 would have to be congruent because they are corresponding angles. 4 and 8 would have to be congruent because those are also corresponding angles, but in a different way. If we look at 1 and 4, hopefully you can see the linear pair, and you can see that those add up to 180. Same thing with 5 and 8. Now look at the markings. One green one and one purple one would have to add up to 180. And if I start looking at my consecutive interior angles, well, I've got one green one and one purple one. Those would also have to add up to 180. So what the theorem says is if you have parallel lines, then those angles that are in the consecutive interior position are going to be supplementary. They will have a sum of 180 degrees. A sum of 180 degrees. Now, this only is true if we have parallel lines. So we have to first meet the hypothesis. We have to have parallel lines. But if we do, then something that we can know is that 4 and 5, which are consecutive interior angles that are on the same side, right? Same side of my transversal T, are supplementary. I'll write it like this. Angle 4 is supplementary to angle 5. There's another pair of consecutive interior angles on this side, 3 and 6. Those are also supplementary. So angle 3 is supplementary to angle 6. Now there's actually 2 more theorems that go with parallel lines that we're not going to learn this year in this class, but if you're curious, one of them is that if you have parallel lines, alternate exterior angles are congruent. And then the last one is if you have parallel lines, the consecutive exterior angles are supplementary. They're not really covered in our course, but I do want to make sure you understand that there are other theorems outside of the 3, well, the postulate and the 2 theorems we're showing you here. So we're going to be looking at these. I know that we looked at them last lesson, but we're going to be looking at these through the lens of proofs. Please notice, all of these are written as if-then conditional statements. If, and then. And the order is important. Now, all of these are reversible, which means I could write these in backwards order as a converse. So I could take any of these, like if parallel lines, then the corresponding angles are congruent. And I could switch my hypothesis and my conclusion. When you do that, it's called the converse. So I've got this postulate, and I can write its converse when I write it backwards. The converse of the corresponding angles postulate is if, oops, sorry. Let me try to undo that. Maybe. I don't know. If, and then still, this is still a conditional statement. But if I know to start off with that corresponding angles are congruent, then something that I can know is that I have parallel lines. Now, postulates and theorems are not always reversible like this in ways that are true. Definitions are. But what we're going to find is that with these parallel lines, that we can reverse all of these statements and still get something that is true. If we know that corresponding angles are congruent, then we're going to be able to know we have parallel lines. So keep that in mind, and we'll come back to that idea in a minute. But the order in which you choose statements is actually really, really important. All right, so let's take a look at this one. Question number 1, we are told that P and Q are parallel. Okay, so we are given that information. Notice that goes in step 1. On your homework, you'll often have to put that step into the proof. The reason for step 1 is always given, and in your homework, you're going to have to write that in quite often. Okay, so those will be blank. It might look like this to start off with on your homework. And what you're going to do is you're going to write the given statement here. You're just kind of duplicating that down. And the first reason is always given. That's always going to be true. So that should be these should be 2 nice easy points for you on your homework. Now, step 3, we have to provide the reason. Please notice we are starting off, if we look at the key word here, we're starting off with parallel for our start. We're ending with things being congruent. So when I'm looking at my choices, I need to make sure that I'm always starting with parallel as my if. Now, all of these do have that. And I need to end with congruent because that's what my proof is telling me I need to end with. This allows me to reject option D. But now I've got 3 to pick from. What I want to do here is I want to be looking at the type of angles that they're talking about and making sure that I'm choosing the correct type of angles. These 3 are all true statements about parallel lines. If lines are parallel, then we do have corresponding angles congruent, alternate interior angles congruent, and alternate exterior angles congruent. However, which type of angles are we looking at? We're looking at angles 2 and 3. Those are alternate interior angles. So this diagram helps us see that the one that we need to pick is option B. Now in your homework, you'll have a list of proofs, a list of reasons to pick from, but you're actually going to write them in. So you would actually write out this statement in words instead of just choosing a multiple choice answer. All right, let's take a look at example 3. Example 3, we're starting off with parallel lines. Again, on your homework, that's not going to be written in. So you would need to write P is parallel to Q, and we know that because that's what we were given as our starting information. So I'm starting with parallel, and again, I'm ending with congruent. So I need to make sure that I am picking a statement that starts with parallel and ends with congruent. I have to reject option D again because that doesn't match what I'm trying to prove. All right, this time I'm looking at angles 1 and 3. Well, angles 1 and 3 are corresponding angles, which means I'm going to choose option A. On my homework, I'd actually have to write that in. Like I would actually write, if 2 lines are parallel, I could just kind of abbreviate like that, then corresponding angles are congruent. Kind of like that. This is how you'll do it on your homework and also on your test. All right, do you remember a minute ago I was mentioning how these statements can be reversible? When we reverse them, we talk about the term converse. Converse just means I change the order. So instead of starting with parallel, notice all of these end with parallel. And the previous conclusion is now the hypothesis. Well, with parallel line, corresponding angles are congruent. If we start off with corresponding angles that are congruent, that's going to be enough evidence to know that lines are parallel. We have to kind of have some evidence, some reason to know that lines are parallel. So if I know, for example, that angle 1 is congruent to angle 5, then that would be enough to know that I have parallel lines. And that would be true with any pair of my corresponding angles. Like if angle 3 is congruent to angle 7, that's enough evidence by this postulate's theorem to know that these are parallel lines. Now, by the way, the names of these theorems and postulates are not important. This is actually the fact that they have names. The names aren't really universal. If we have a district exam in a different year, then we use these names that the district exam uses them. We're not going to have a district exam this year, so we're going to write them out as if-then conditional statements instead. Okay, so don't worry too much about the names. Worry about the order. Worry about the information that's embedded in it. So there's 2 more sets of corresponding angles. So we could have also done this with like angles 2 and 6. If we know that angle 2 is congruent to angle 6, and we know that those are corresponding angles, that will be enough evidence for me to know that I have parallel lines here. Same thing if I know that 4 and 8. Because those are corresponding angles and they're congruent, that will provide the evidence to know that I have parallel lines. This second one is another converse. We have taken the alternate interior angles theorem and we're writing it in reverse order. That's called a converse when you write something in reverse order. So we're instead of starting with knowing we have parallel lines, we're finding out what evidence we would need to know that we have parallel lines. Well, with alternate interior angles, they're supposed to be congruent. If those are indeed congruent, we have enough evidence to know that we've got parallel lines. So if you know, for example, that 3 and 5 are congruent, that will be enough information for you to know, yep, we've got parallel lines. Same thing with 4 and 6, if you know that those alternate interior angles are congruent. The last one here, the last converse, is the converse of the consecutive interior angles theorem. Remember, converse means I'm just reversing the order. So instead of starting with parallel lines, I'm ending with parallel lines. And I have consecutive interior angles, and these consecutive interior angles, they're not congruent. The consecutive interior angles are supposed to be supplementary with parallel lines. And if indeed they are, then that's enough information to know I've got parallel lines. So for example, angle 4, if angle 4 indeed is supplementary to angle 5, then I would know that I have parallel lines. Or if angle 3 is supplementary to angle 6. Now you might notice I'm not marking on my diagram here. It's very hard to mark supplementary. There's not really a symbol for it, so I'm just going to leave it like that. Okay, so on these ones, look at our proof below. Look at our key phrases for our given and our proof statement. We are starting with congruent, and this time we are ending with parallel. So I'm going to be choosing one of these 3 here for my reason. And my reason needs to match. Okay, so these keywords need to match. All right, well, notice on this one, I've got a little bit more blanks. So in the first blank, you always write the given statement. It's kind of just a copying down here. And the first reason is always going to be given. You'll be doing that in your homework. Those are easy points. All right, so now the angles I'm looking at are 1 and 2. They're congruent. I'm going to mark them to help me focus in. I can tell I need to be starting with something congruent and ending with something parallel. This means I'm either going to be using this first one or the second one. I'm not going to use the third one because it's not starting with congruent. So I'm not using that one right now. Okay, I might need it later. Let me unmark those. To decide which of the first 2 I'm using, they both have the same keywords in the same order. I need to talk about what type of angles I'm looking at. So angles 1 and 2 are corresponding angles. So I'm going to use the first one. I'm going to do a little abbreviating. So if corresponding angles, I'll kind of abbreviate that. Whoops, I'm having a little trouble writing. Let me, okay, there we go. So if we have corresponding angles, I'll abbreviate that and I'll use some symbols, are congruent, then that's enough information for us to know that we've got parallel lines. All right, let's take a look at number 15. Again, when you write the statement for number 1, you are just copying down the given information. The reason for step 1 will always be given. You will never have to question that. There will be questions like that on your test, so that's going to be nice. You're going to know what to do there. Okay, so I'm starting with supplementary as my keyword. I'm ending with parallel as my keyword. The only one that actually matches this is my third one here. So that's, let's just check. We're talking about angles 1 and 2. Angles 1 and 2 are in the position for supplementary angle, or for consecutive interior angles. So this is a good fit with this last theorem. So I'm going to abbreviate a bit. So if consecutive interior angles are supplementary, make sure you have the right keyword at the beginning, right? Sometimes people just start writing really fast, but make sure you've got that in your hypothesis. Then that's enough evidence for us to know that we have parallel lines. And again, you can use symbols in there to help with just the amount of writing that you have to do and the amount of space it takes. That is the end of our notes for 3.5.